We will now have the first half of the lecture with this group, and then after the first part, Dave and the other students will join, and we will do some error message interpretation and debugging for the last part. So kind of tell you a bit about those things. But yeah, so let's start with the Pandas lesson. So again, we have separate lesson for Pandas and NumPy as last week, and so we have the Pandas and advanced data processing in here. In the lesson page, the student binder or the binder does not work at the moment. I will fix that right after the lesson, but the CSC notebook works. So if you want to follow, use the CSC version of this lesson. What we will do today is that we will basically use, well, again, weather data from NOAA, and we will kind of work on that kind of data and see how we can aggregate data, for example, and do some useful things. The overall aim for this week in the lesson is that we want to kind of analyze and detect outliers in the weather data. To basically, the idea is that if we are able to detect storms using well, weather data from last year, the summer of last year. So that's kind of where we are heading, and I will kind of introduce you different things that are useful in Pandas so that we can actually detect those outliers in wind speed and so on. I have my Jupyter Lab already opened here at the CSC version of it. So the data that we have is basically looking something like this. So we have kind of an ID for the weather station, and then we have a lot of different attributes. This is something that you saw in the exercise, so it should be somehow familiar for you what the data is about. So let's start continuing working with that. So the first thing what we want to do is that we want to read the data into the Pandas. This is basically what the data looks like when we open it. So it's a text file with the records from, I think these are August 2017. So daily or hourly, now I don't remember. I think they are somehow hourly data from that year. Well, we will soon learn more. But let's start going through, and the first thing what we want to do is to read the data file in. So we are going to use Pandas to do that. So we need to import Pandas as the first thing. Then what we want to do is that we want to specify what the file path to the file that we want to read in is. So as we can see here, so this is the Jupyter notebook what we are now operating in, and we have this data folder here, and here we have the file. So what we want to do is that we want to specify that the relative path to that text file. So I specify that file path equals to data slash and then the name of the file, which is something. Let's see if I can copy this one. At least if I check the rename here, I can get the text, and this is the file name for that file. It's a bit tricky one. And then the last thing what we want to do in this part is that we want to read the data. So how do we do that? Is that we had in Pandas this read CSV function that we use, and as the first parameter, the read CSV function wants to have the file path to the file that we want to read in. So we specify the FP to be the file path. Then we need to specify a separator. And in our case, there is a kind of what is separating different columns from each other is that there is varying number of these kind of asterisk characters. And there is a way in Pandas how you can deal with those. And there is a note in the lecture materials about it. So in addition, separators longer than one character and different from blah blah blah. But anyway, the main thing here is that with this kind of string, sep equals to \s plus. So this is a way how we can read data that has varying amount of asterisk characters in here. So we can do that. So let's specify that the separator is like this. And then as the last thing what we want to do is that we want to specify what are the non-values. And the non-values in our case, they are the same as in the exercise. So basically we have varying range of these asterisks. So I just copy paste this from the materials. If you're following, you can do the same. And now as a final result, we have these kind of parameters given to our read CSV. And then hopefully when executing, nothing comes to the screen, but something happens. So we should have something in our data variable, which is a data frame. So yeah. Yeah, I mentioned that when I started. So take the CSC notebook version. I will fix that link later today. But yeah, I just saw it like 2 minutes before starting, so wasn't much that I could do. But yeah, so let's continue. So when we print the data and the head, so we get the first 5 rows in here, and we can see that the data looks okay. So we have different columns. We have non-values in here, so it means that our kind of parameter and specification of what kind of characters should be interpreted as none seem to be working, and that's good. So we are kind of good to go and continue. So let's explore the data a bit. So of course a good thing to check always when starting to work with new data is to, well, see what kind of columns do we have. So indeed we have quite many columns in this case. And typically, at least what I do when I do analysis with some new data, and there is a lot of variables quite often, but the reality is that typically you are interested in only few of those columns. So what I do quite often is that I basically select only those interesting columns to me, and then I continue working with the kind of smaller data frame, just to make things a bit easier to when you look at the data, so you don't see like 30 columns, but you see only 5 or 6 of them. So let's do so that let's select the interesting ones for us that are useful to detect the unexceptional weather conditions. And what those columns could be, weather anomalies. So let's create a select calls variable, and let's make a list of those columns that we are interested in. First thing, what is definitely useful is the date. So this column called YR blah blah blah. So that is definitely useful. So let's put that in there. The other interesting column for us that could probably be useful is this dir, which is, I guess, the direction of wind. Then we have a column called SPD, which is the wind speed, kind of average wind speed. Then we have a column called gus, which is gust, so if the wind is blowing really fast at some point, so we have some information about those. And then we have temperature and the maximum and minimum. I guess the temp is the average temperature, and then we have maximum and minimum temperatures. So let's take all of those as well. So as a result, we have around seven columns that we want to select, and let's do the selection by saying that data equals to data, and then inside the square brackets we just specify what columns do we want to select inside a list. So what I do here is that I just specify that data square bracket select calls, and what will happen is that it will basically override my original data variable and only leave me with these 7 columns in here. Let's see if it works. No errors, so things seems to be okay. So let's see what do we have in here. So there is also a useful function to check the last rows of a data frame. So we have seen many times the data.head, but there is also another one called data.tail that shows you what are the last 5 rows in our data frame. Let's also check what are the data types in our data frame. So we can specify that data.dtypes. So in this way I will print some text in here so that it's easier to see. So yeah, so this is the last 5 rows, and here we have the data types for different columns. So it seems that we have integer values in quite many of our columns, and then we have some floating point numbers in our data frame. I guess these should be quite familiar from last week already. We did these kind of things quite a few times, and I guess you also practice those in the exercise. If you have any questions at any point, so just raise your hand and I will try to answer you. Then what is kind of obvious from our data frame here is that the column names that we have are pretty awful. For example, if I would like to do some calculations with this date information here, I should call this YR modern all the time. So it is quite often useful to rename your columns in a way that they are easier to use, easier to understand what they mean, and so on. So let's see how we can change the column names and rename those. So how the renaming happens is that we have a rename function in Pandas, and what it takes as an input is a dictionary of key and value kind of pairs. I will shortly explain you what those are. Let's first create the kind of conversion dictionary for the names. So how you specify a dictionary in Python? Dictionary is a kind of a similar thing as list, so you can add things inside a dictionary, but it works a bit differently. So empty dictionary is defined with these kind of curly brackets, and these are quite powerful kind of data type, and what they are good at is, for example, in these kind of situations where we want to specify that the old name that we have in the data frame is called this YR dash dash MODAHRMN, and this is the kind of original name in our data frame, and then we want to rename it. So this is kind of a key for our conversion, and then the value that we want to change that is something that we give here after this colon. So this is how dictionaries are typically used. So we can specify that instead of saying all the time that this is the date or time, let's just call it time, which is much more easier to understand and also easier to use when doing the calculations. So this is basically a simple way of creating a dictionary in Pandas, and the kind of key things to understand is that typically you have some kind of key and then a corresponding value for that key. Let's maybe explain this a bit more. So now I have created that dictionary, and if I want to, for example, see what is the value in this key, so I can call name conversion dict. So this is kind of a similar approach as using list. So we have a certain index value and then we get the value. But dictionaries work in a way that instead of using index values, we call the name of the key to fetch the value in here. And the indices can be whatever. They can be numbers, but they can be strings or whatever you specify them to be. So if I copy paste this, I should get the value from this key here. And what I get out is the time, because it was the value associated with this one. So this is kind of a really quick introduction what a dictionary is in Python and how you can basically use it and get the values. And soon you will see why this is useful. Is, for example, in our renaming case here. Let's also specify a couple of other columns that we want to rename. For example, the SPD, which is the speed. So let's change that instead of using SPD, let's kind of write it as speed, which is kind of more intuitive. And then let's rename also the Gus to Gust, so we kind of open up what those terms mean. And now I execute this, and then I remove that one, and then I want to, well, let's first check the data type. Name conversion list. No, not list, dict. Oop. So from here we can see that the data type of this one is a dict dictionary, a bit similar than list. So when we do the renaming, so we indeed, yes.
So you said instead of year, Moda, Hartman, you could put in a 0 in that.
In here.
In the subsequent.
You mean this?
lookup function. No, when you were doing the with the brackets, with the square brackets.
Oh yeah, when I called or kind of. So you mean when I did this?
Yes.
Yeah. So the question is, can I do this?
Correct.
Well, let's see. No. And this is kind of a difference between a list and a dictionary. Is that in lists you are kind of working with the indices of those values. But in here we are not working with the indices, but we are working with the key value pair. So whenever I want to take something, I need to specify that take the value from this key. So if I would have a kind of a key pair value that this would be 0 and then the value would be time, then this would work because we are again kind of but yeah, that's how it works. So there's a bit of, they work a bit similarly, but not quite. So this kind of thing doesn't work. But for example, if we want to take the speed, the SPD from there, it works because it can be found from the keys of this dictionary. Name conversion dot keys. This is the way how you can actually see what kind of keys are available in this dictionary. And the same thing for values. You can see what are all the values in this dictionary. Just a quick side note. But yeah, so let's continue with the renaming part. So indeed, we want to use this dictionary to rename this column as time, this SPD column as speed, and this gust column as gust. So rename the columns. So how we can rename is that we specify the data frame. So this data, which is the name of our data frame, equals to data.rename, and then we specify the columns parameter that takes the dictionary as an kind of input. So this name conversion dict is what goes in, and then we can print the data columns. Actually, let's do so that we say that after renaming, and then I do before. This is something you don't need to do, but just to clarify this point. So now when we execute this, we see that before we did the renaming of those columns, we had these column names, and after we executed this function, we had the time, dir, speed, gust, temp, max, min. So all the kind of keys that was found and that were kind of specified in here were converted to a new column names. So this can be quite useful thing when you have funny column names and you want to make them somehow more intuitive or shorter, for example. Let's continue. Really the kind of first things what you always want to do when working with new data, whether it comes from this kind of weather data that we have or any kind of data really. So you want to kind of explore a bit what kind of values do you have, and do some kind of basic statistics out of the data that you have. And a good function for that is this data.describe that we showed quickly last week already. So when we print data.describe, we get kind of a overview of the columns that we have, how many values there are on each column, and what is the mean, standard deviation, maximum, and so on. from here. What is maybe now thinking of our kind of aim in here is to identify the weather anomalies. So it seems that in most of the cases we have 72 observations, so the count is 72. But as we can see from here, the maximum and minimum variable only have two values in the whole data frame. So we can basically already now say that these max and min values are most probably not useful for us because there's just no data in those columns. But temperature, speed, time, direction, and also probably this gust that has 20 observations in this data file might be useful. But let's take a better look of our data and let's print the first 30 rows of the data to understand a bit better what is going on. This is also always good to kind of visually go through the data file. So indeed we have the time in here. It seems that the time that we have is, this is the August 4th of it, and then we seem to have values at 00 sharp, 20 past midnight, 50 past midnight, and then the next value is at 1 AM, and then again 2050, and yeah, and so on. So it seems that we have kind of a irregular interval in the measurements in the data. So this is something kind of good to understand, that this is what we have in here. Then when we look at the gust where we had the 20 observations, so let's take a look at that. So it seems that we have quite a lot of non-values there, but then at 2 AM we seem to have one, at 3 AM we seem to have one value there, at 4 AM and so on. So already looking at this we can basically observe that it seems that in the other attributes we have measurements more often than with this gust. So this gust is measured at every hour sharp, but not more often than that. But basically this can be already useful for us. So I think we can use this gust data when proceeding with the analysis. So now when we start proceeding, let's see a useful thing in Pandas and in programming in general. So let's use a function that we have made by ourselves, and let's see how we can apply and use the function in the data frame. Again, we are doing the same thing as many times before, so we convert temperatures from one to another, so from Fahrenheit to Celsius. So these temperatures in here are Fahrenheit, and we want to convert those to Celsius. I have this function here already defined, so I just execute it. So I have this function now in memory to save some time, but basically what we have is that this function takes the temperature in Fahrenheit as an input parameter, and it returns the Celsius kind of value as an output. So how can we iterate over rows in Pandas? Is that there is a specific function for that, and basically how we do it is quite similar as for loops in Python in general. So we use the for and so on, and we have some kind of collection that we are iterating over. It can in Python, in normal Python, it can be a list. In this case, we want to iterate over the rows in a data frame. So let's see how we can do that. So iterate over the rows in a data frame. So as always, when creating for loops, we start by specifying that for, then we specify, this is now something different, for index, and then the row that we are specifying or iterating over in data, which is the data frame that we want to iterate over, iter rows. So there is this kind of function called iter rows that basically iterates over a row at the time of a data frame. And because in data frames we always have the index value, and then we have all the rest of the rows, so the columns and so on. So basically what this iter rows does is that it gives you not only the data values, but it also gives you the index value. So this is the reason why we specify two variables here. So the first one will contain the index value of that row, and the second one, called row, includes all the values that are associated with that specific row that we are iterating over. So let's check a bit what we have by printing some stuff. So index. So let's do so that let's just print what is the index value in here, and let's print the row to see what is happening in here. And so that we won't have like the whole thing in our screen, we can stop the iteration by specifying this command in Python called break. So this is kind of a special command used in loops, so that you can, whenever this command break is hit, it will stop the iteration of that loop, and that's basically what it does. So now we will go one row and see what the index and row value in there is. So let's see. So the first thing that was printed on the screen is indeed the index in here, and the second thing that was printed, which is basically this stuff in here, is the values of that row. So it is exactly all the contents that we have. So we have the time column, their speed, gust, temperature, and so on, and then we have the associated values in each of those columns. Let's check what is the data type of that row as we now have it in here. So it printed into here, so we can see that what this row actually is. So it is a Pandas series representing that one row in here, and it works exactly the same as all Pandas series in the data frame. Do you have a...
Yeah. So when you re-executed that cell, how come it didn't go to 1, from 0 to 1?
Because whenever I execute this, it will always start from scratch.
Okay.
So it will always kind of start from the beginning of the data frame, and it will always kind of start from 0, print the first row, and then it kind of stops when this is hit. So that's the reason. So there is a way how you can kind of one by one kind of go increasing, but it's maybe something that we won't cover in here, but just that you know that it's possible to do. So we have Pandas series, we can do loops, in our data frame. And then basically what we can start doing is that, well, if we have this series and we have the values in here, so we can start doing all sorts of calculations with these values. And the thing what we want to do in here is that indeed we want to take the temperature, which is in Fahrenheit here, and we want to convert that to Celsius. So let's kind of continue from that, and let's see how we can kind of update the values in a new column in our data frame. So first of all, we need to have a place where we are actually updating these values. So we need to create an empty column to our database, or not database but data frame. And let's call that our column name equals to Celsius. And then how we are able to create a column in the data frame is that we just specify data, and inside square brackets we specify the name of that column, and let's initialize it just with none values. So this will create an empty column with nothing but none inside. And then when we have the kind of place where we can update and store the values from the conversion, then we can basically iterate over the rows and update and convert temperatures. So let's kind of repeat what we did previously. So let's create a loop. So for index and the row in data dot iter rows, and then this is a function, so you need to specify the parentheses in the end. So now we kind of initialize the for loop, and then what we want to do inside here is that for each row we want to convert the Fahrenheit to Celsius. So how do we do that? Well, we can say that let's store the value temporarily into this Celsius variable here, and we can use the function that we defined here earlier. So I just make sure that it's definitely in the memory. So I can use this var to Celsius function and convert the Fahrenheit. So how do we use the function is that we need to, again, whenever you use the function, so you need to call it. So defining the function does not do anything, but when you are calling the function, then it starts doing the stuff. And what we want to pass as an input is basically the value of the temperature column in here. And how we can get the temperature is that we specify that from that row that we are iterating, take the temperature value. So in row and the square brackets, you specify what is the value that you want to take from that row, pass it in to this var to Celsius function, and then the value that it returns will be stored in this Celsius variable here. Let's see just by iterating the first one in here, and let's see what happens in this case. So now we should have this Celsius defined. Nothing happened because I didn't print anything or store it anywhere, but when I call Celsius, I should have a value, and indeed I do. So this is basically now the Celsius from that row temp. We can see that what the row temp is. So we can see that 58 Fahrenheit seems to be around 14 degrees in Celsius. So great. Now we have iterated one row, we have converted the value. So the last thing is that we want to update that value into the data frame, into the new column that we created in here. So let's do that. So update the value into the data frame. And this is also something that you have practiced already a bit. So we use the .lock, so data.lock, and then what is the position what we want to update, so the index. Well, we store the index value in here, so it's good, so we can take advantage of that. So at the index that we are iterating over, update the value in the column name, so we can specify that the column name, so, and this column name is Celsius in this case, and let's say that the value will be this Celsius in here. So now what is happening is that we convert the temperature first and then we update the value, and that's it. So when I execute this whole cell, nothing happens, but now when I check what the data looks like by printing the head, so now we have this new column called Celsius in here, and then we seem to have the 58 Fahrenheit seems to be around 14 degrees, 59 seems to be 15 sharp Celsius. So this is kind of how we can use our custom-made functions. One way of doing this. There is also a more efficient way of doing and using functions in Pandas, but we will learn that later in the second period if you continue on the AutoGIS part. But this is kind of easy to understand now as you have done for loops. So let's stick with this one for a moment now. Good. Let's see, well, let's do minor things still. We have the speed values here. Actually, no, I check if I might just skip this one. No, yeah, I need to do it. So let's convert the speed, wind speed values into meters per second, as they are now miles per second. So let's yeah, here is by the way a note. So the apply function, here is a link that you can use to check how apply can be used. But anyway, we won't go through that now. But what we want to do is that we want to convert those wind speed values into meters. So how we can do that? So let's convert the speed to meter per second. So we can say that data speed, so this is always a bit dangerous to overwrite stuff, but let's now do this carefully so that we do things correctly. So let's update the data speed with this formula 0.4474. So this is basically just a factor that kind of converts the mile values, miles per second, into meters per second. And let's do the same for gust. Great. So what we have now is that we should have, let's create a new one, data.head. So now the speeds have been converted into meters per second. So that's what happened there. We will use that later, so that's why we did it. So next thing, let's see a bit how we can do string manipulation in Pandas. So this is also something I think you practiced in some of the exercises earlier. So how you can slice strings and so on. Is there any questions, by the way, at this moment? Have this seemed more or less understandable? Kind of iterating over rows of a data frame is the main point at this stage. No? Good. Well, let's then continue. So what we want to do next is that when we take a look at the data again, so let's print the first 20 rows. So we can see that this time contains quite a lot of information about the year, the month, the day, the hour, and the minutes. So what we want to do is that we want to kind of aggregate our data based on these hourly values in here, because this gust is kind of measured only once in an hour. So what we want to do is that we want to kind of parse the hour from this time, and we can use string manipulations to actually do that, so that we first convert this number into a string, then we isolate the hour of that from this information, and then we can actually group those hourly values and, for example, calculate the mean wind speed or mean temperature or whatever we want to do. So that's kind of the goal where we are heading at this point. So there are some incorrect links in here. So first thing what we want to do is that when we, let's take a look at the data types again, the types. So we can see that the time column seems to be integer in here, but as we want to do kind of string manipulations, the first thing is that we want to convert that integer into a string so that we can start slicing parts of the text in that one. So let's convert time to string. So in the data frame that we have, I create a new column called data underscore str string, and what I will assign to that column is that I will take all the values from this data time column, and I will convert that with this as type, which is again something that you have seen previously, and I will convert that as type string. So this is basically what will happen, and let's then print the data types. And let's see, what do we have after this. So now we executed this, and now indeed what we have here is that we have this new column called tame underscore str, and the data type in this one seems to be object. That doesn't tell much at this point because, well, object can be quite many kind of things, but let's take a look and kind of slice or take one value from that data frame, and let's see what is the value at position 0 in this new time str. So when executing this, we can see that indeed the original integer value has now been converted into text, because we have this single question marks in here, and that is kind of a message that this is now in text format in here. If it would be integer, it would be just a number. So that's good. So we can kind of continue. Actually, well, I will just continue a bit. So I will create a text sample variable and just demonstrate a bit what we can do. So what we have now in here is that in this text sample, it is a piece of text. And if you remember from, I don't remember now, is it first or second lesson, but indeed we can take slices from this text by specifying inside square brackets, like take the stuff from 0 up to, let's say, 5. And basically, well, let's take to 4. So what we have here is now we have kind of sliced and taken only the year from that text. And this is kind of the approach that we want to do, and iterate over each row and not slice the year. Well, we can do that as well, but we are interested in the hour information in each row. So that's where we are heading now. There is a nice function in Pandas for doing this kind of slicing in a data frame directly. So we can slice the string, and we can say that data, again we will create a new column in our data frame. So let's create time, is it DH data hour? I don't anymore remember what was the kind of acronym for that. So let's create this kind of column into the data frame, and as an input, so we created this time underscore str, so we will kind of iterate over those values, and we will do that, take the time string, and then we can specify kind of direct functionalities in Pandas. So .str, so in here you will get kind of different text manipulation functionalities, and what we want to use here is to use this str.slice, and this is kind of works in a bit similar manner as this range function in Python. So we specify what is the starting position, let's say that it's 0, and what is the end position in there, let's specify that it's 10. So, and then let's print data dot head again. So oh, it's not end, it's stop. So this is the correct parameter, so start and stop at 10. So what this function now did was that it took the values from this time or this time string, and it sliced all the values in a way that now we have everything up to, so we have the year, we have the month, we have the day, and then we have the hour. But what was cut out was these minutes from here. So now as a result we have something, so we have again, we have 3 values that are basically on the same hour, and now what we can do is that we can basically calculate the mean temperature from these 3 values, and that is where we are heading next. So yeah, well, before doing that, we also want to have the hour from that. So let's kind of use the same approach. Slice the hour from the data. So let's create data time underscore h, which is hour, equals to data time str. So we are doing exactly the same thing as before, and we use this string dot slice, and then now the starting position is at 8. So when we calculate basically these, so 0, 1, 2, blah blah blah, so around 8 we should have the hour information, which is this location, and then the stop is at 10. So and then what we want to do is that we can also convert, well, let's do this first. So now what we have here is that we have this new column time underscore h, and we have these 0, 0, 0, 0, 1, and as we can guess from here, these are now text. So we can, because these are still, they are all kind of numbers, so we can easily convert these into integer numbers, so that it will basically try to it reads the text in, and if it can convert it to a number, which in this case it can, so it will do that. So let's convert the hour into integer. So we can just say that data time h equals to data time h dot as type int. And when now looking at the data, so as you see, nothing basically changed, but now instead of having double zeros or 0, 1, now we have zeros and ones, which are basically numbers in our data frame. Good. So then we're heading to the aggregation part. So now we have kind of processed our data in a way that we have information not in 20-minute intervals, but we have them in hourly basis, because we extracted and sliced that hourly based data from that column. So we want to calculate the average temperatures, wind speeds on the hourly basis based on our data at this point. And how we can do that is that we are grouping all the values that belongs to the same hour, and then using that group we calculate the mean, median, standard deviation, and so on if we want. And there is really handy function in Pandas called group by that can do just this. So whatever unique values you, or not unique, but whatever kind of values that are same or similar, so that you have like a, well, in this case, for example, these hourly based values, so each one of them that has a same value in certain key, it will be grouped together, and you can work on those. So before we or in the beginning, what we want to do is that as we have here, we have quite a lot of data, but now because, for example, these three values will be combined together, so actually we are reducing the amount of data in our data frame. So what we need to do is that we actually need to create a new data frame where we are actually inserting the aggregated values. based on these three kind of group of three values. So the really first thing is that we create a new data frame for the results, and we can call it agger_data, so aggregated data, and that will be just an empty Pandas data frame. And that's it. We can even see that it's an empty data frame when we print it. So indeed there is this group by function in Pandas. So let's group the values by date and hour and not minutes. So what we did earlier was that we have this time dh, so there's day and there is hour information, but not minutes. So we use this as a key to group our values. And how we can do that is that we create this kind of object called, or variable called grouped, and we use the data, which is the data frame that we have, dot group by. So simple function that we can use, and as a parameter we specify what is the column that we want to use to group the values by. And in our case it is the time underscore dh column, so this one. So we have information about year, month, day and hour, and that's what we want to do. And let's execute. So now what happened is that we created these kind of grouped variable in here. We can see that what is the type of that grouped variable. So it seems that we have this kind of special data type in Pandas called Dataframe group by. We can also see how many different groups we have from that data frames by just taking the length of the group. So indeed it seemed that it found 24 different groups, and well, we had 1 hour of data in our data frame, so this makes perfect sense that we have 20 hours because we have different groups for each hour of the day. So that's what we have. So how can we now start working with this group by object that we have? Is that, well, I have specified already kind of a key. So this is the same thing as we saw with the dictionary. So we have key and then we have some values. So this is the first kind of value in here. So this is basically just this string number, well, string set from here, and we can get a single group or select a group by specifying, for example, group 1 equals to from where do we get that group is the grouped variable, and we have a function called getGroup. And what is the kind of parameter that we pass in? Well, it's the index or kind of the key of the day and hour that we used. So let's see what do we have once we do this. So now as a result we have a group of 3 values in this group 1 variable. So we have the 0 sharp, 20 past midnight and 50 past midnight, and they were all kind of grouped together. And if we take a look what is the type of this one, we can actually see that we have a data frame, which is nice because, well, we have already seen what kind of things we can do with data frames. So all those possibilities that there are for doing any kind of calculations or manipulations with data frames are now available for us, which means that we can, for example, really easily calculate the mean, minimum, maximum values, and so on. And this is basically what we want to do next. So let's do so that we have these variables in our data frame. Yes.
So just to be clear, going back to that, so that data frame is 4 rows, right? Am I getting that right?
Yeah, it's basically should be 3 rows. Yeah.
Okay.
3 rows.
2 rows.
Yeah, so there is 3 values for each hour, and those were grouped together. And that's what we have. We can see that from this time_age that all these values belong to the same hour. Yeah, good. So let's continue. So now what we want to do is that we have these kind of groups for each hour. So we want to calculate the mean of each of the data attributes that we have. So we have the direction, we have the speed, cost, temperature, and we have the Celsius. So what is nice in Pandas is that we can basically calculate all these at once pretty easily. So we can just specify the columns for calculation by creating a list of values. So we create a variable called mean cols equals to, and then the list of column names that we want to include in our calculation. So let's say that their speed, gust, temp, Celsius. No, it's like this. Well, we can also, well, that doesn't make any sense. Let's keep it like this. And then when we have defined the columns that we want to aggregate, we can just calculate the mean values. And we can create a variable called mean values equals to, and in the memory we have this group 1, so let's use that group to demonstrate this. So let's say that group 1, and then inside the square brackets we specify all the columns that we want to process at this point, and those columns are the ones defined in this mean cols. And then what do we want to do? Well, we want to calculate the mean. So dot mean was the function that we can use to calculate means easily. And let's see what we have after we execute this. So now we have kind of we aggregated the 3 rows in our data frame and calculated the means of each one of those. So if I print the original group 1 below, like this. So this is the original 3 rows data frame, and this is the result. So instead of 3 rows, now we have 1 row basically in here, and these values is basically this there. Where is that? Here. So this is basically an average or the mean of these 3 values, and the speed is the average of these 3, and so on. So this way we can basically do aggregation based on groups. And yeah, and the last thing that we want to do, so at this point we have the values, but we don't have the time that is associated with this. So as the last thing, what we want to do is that we want to basically add one more value into this series now, and that value would be the time. So update the time information. So let's say that mean values, which is the one in here. So let's create a new column there and say that time dh equals to so what is the time? It is basically the one that we used for grouping. So in this case it will be the value from this variable time1. We will soon see a better version of this, but we can say that the value from that variable will be the time, and let's print the mean values after doing this. So now we have the values, and then we have the time information as well, and that's good thing. Then now we have processed one row, but then as we kind of want to do this for each row and each group at the time, we want to append this into the data frame that we created in the first. So here we created the data frame Aggregated. So let's just do the one last step and update that. So let's add the aggregated value into the data frame. And how we do that, this is also something that you have seen. So we just specify that aggregated data equals to aggregate.append, and what we are appending there, well, it's this mean values, and then what we want to say is that we want to ignore index, so that the index value will be kind of sequentially increasing what we'll do. And then let's see what we have once we have done this. And there is something wrong.
Yeah, true.
Okay, let's.
Using an R in the ag data print.
Oh, great. Thanks. Yeah.
You want to ignore the index, right?
Oh yeah. Yeah, maybe I missed one point. Let's take a look now. Mean values. Let's see what is the type of that. It's a Pandas series. And then let's take a look. What is the data in here? Oh, yeah, it's an empty data frame. Well, let's. Oh yeah, my bad. So it needs to be true, and that was kind of the thing that I wanted to do to few sleep last night. But yeah, so basically what we have now is that we have a value in our new data frame, and we have the aggregated values in here, and we could basically now go through and pick the different groups from the data frame that we are iterating over. But of course that is not something that we want to do. but we want to iterate over each group that we have identified from that large data frame, and we want to update that. So what we can do is that we can exactly iterate over the keys in this keys and the group values in this grouped object that we did. Just to remind what we are doing here. So in the beginning we grouped the values by this time underscore day and hour information, and now what we want to do is that we want to iterate over all of those groups and update the data frame. So what I will do actually, so I will initialize the data frame again so that it is empty once we are doing this. So Aggregate data equals to Pandas data frame, and it is an empty one, just that we have a clean data frame when we start doing this. And then what I want to do is that I want to use these columns that we specified earlier, so these columns to calculate the mean temperatures. So I just copy and paste this in here, and then what I want to do is that I want to aggregate the data by doing the mean values equals to, and now what we are calculating is that we want to use the group in this group. So now we are iterating over 24 different groups from this grouped object in here, and I want to use these mean columns and calculate the mean. So we are doing exactly the same things that we did before, but now we are iterating over all of those groups in one go. And what we also want to do is that we want to add the key. So this is the key that was used to group the values, which is the year, month, day, hour string. So we update the mean values time dh equals to key, and then we want to append these values into this data frame. So add to result data frame, and we do that by specifying Aggregate data equals to Aggregate.append, and what we are appending there, well, it's the mean values that we calculated here, and we need to ignore the index, and indeed it needs to be true, not false. So I do this for the first group, and I will show you what we have. So now basically what is the key in here? We can take a look. So the key, indeed, in this case, now we are on the first group, so it is the string of this date information and the hour information. What is the mean values that we have here? It is the Pandas series. Pandas series having all the values of the aggregation, and at this point, what is the Aggregate data? Well, it's the data frame with only one value because we stopped the iteration in here. But when I remove this break and run it again, and let's now check what do we have. So now we have aggregated values for each of these hours, and we have the average speed, temperature, gust, and so on. So this is kind of a quite powerful thing. I use these kind of grouped I group values quite often and do all sorts of aggregation, so it is really useful when dealing and processing data, when you have some data values that are, for example, recorded in different intervals. So then you need to kind of match and munch those together, and this can be quite handy tool for that. Cool. Then we have still a few minutes. Let's have a break at quarter to 11, and then we end with the or then we come together. So the last thing is that now we have the average values in here, and now we want to detect the storms. So maybe just to save some time, I could show you the one for the larger data frame. So you can go through the materials yourself and play around with executing the stuff, but just to save some time, I will explain what we want to do, and then I will do the stuff with the larger data frame. So what we want to calculate and detect from the data is that we want to find outliers based on the wind information. And how we define an outlier here is that we specify that an outlier is if the wind speed is 2 times the standard deviation higher than the average wind speed of the whole data frame. So it is quite kind of a lot higher or stronger wind than what is the average of the wind. So there are how do we do that is basically that we want to calculate the standard deviation of the speed, which is the wind speed in here. So this is something that you have seen already and used quite often already. So we calculate the standard deviation, then we calculate what is the mean wind speed in that data frame, and they seem to be, well, 1.6 is the standard deviation, and the mean wind speed has been 5.1. And then we specify the threshold for detecting what is an outlier. So as we specified, the threshold for being a strong wind is the average wind speed, which is this one, plus the standard deviation, which is this, times 2. So what comes out here is that the standard deviation, the upper threshold is something around 8.4 meters per second, and that is kind of detected as a strong wind, an outlier in the data. And what we then do, this is also something that you have done earlier, so we use conditional statements. We iterate over the rows, and we check for each row that we are iterating over, is the speed of that row at that hour, has it been higher than the threshold that we specified in here. If it was higher, then we specify that the outlier equals true. So this is an outlier based on our definition of an outlier. If it was lower than the threshold, then we specify false. And when we calculate this for the whole data frame, we get this kind of a new column here with a lot of false, but we seem to have also one true value in here. So based on this definition, in that one day we had 1 hour that seemed to have strong wind, and the wind at that point was 8.9 meters per second, which is, well, not that strong, but still fairly windy. So what I want to still show you interactively is that this is not these values and this approach was basically based on only 1 day observations. But what if we take the whole summer and repeat the same thing? Then we have of course much better kind of data, or more data to do the data analysis. So I will skip that one and I will basically yeah, I thought I had the whole thing in here. Well, I will just copy and paste this, which has all the steps that we did previously, and I will paste that into here. So step by step. Now instead of using the sample data, which is only 1 day, we use this August data frame that has much more observations. So we have data for the whole August, and then we read the data, we do the renaming, we do all the stuff that we did earlier, we convert the temperatures and so on, and then we do the detection, and as a result we have a kind of a new data frame with the aggregated data, and then we have also a new data frame where we have detected storms. So let's see what we get once we run this. It takes a few moments, and now we have something in here. So now basically we should have in this aggregated data we should have quite a lot of values in here, because now we have hourly data for the whole month of August. So we have 742 rows in our data, and we have the 8 columns. And then what we have here is that we have the outlier variable, and we have the average speeds and temperatures and gust as well. So then we have the storm variable, and what that is that as we had detected those outliers, so in this storm variable what I did was that I only selected those rows that had true in the outlier variable. So those were identified as outliers. So let's take a look what we have there. And we seem to have quite many rows. Let's do it like this. So we have this many hours in our data that was detected as outliers. And what we can see from here is that the gust, the speed, the variation in the speed is not that kind of strong or high, but when we take a look at the gust, which is kind of when the wind is for short moments blowing really fast. So here we can see that there is more variation, and we can see basically that we have one extra high value in here. We can take a look of the sort values and sort those. So if we take sorted equals to storm dot sort values by gust, and let's say that we want to have them in descending order, so we specify that ascending equals to false, sorted data, and then print sorted data. So now we basically sorted this data frame based on gust, and we can see that this is something quite extraordinary. And what that day was is that it was basically something that made this happen. So it was this Kira storm last, I don't know how many of you remember that. It was in the August 12th when I borrowed my mom's car and there was a huge tree basically falling just next to it, not on top of it luckily, but yeah, it was quite a strong wind, and that is definitely visible in our data. It's almost twice as high this gust speed during that day as normally.